Hey, welcome, and I'm glad you're here. So, in the next 15 minutes, I'm going to show you how to build a real working price tracker using Python and PostgreSQL. And when I say real, I mean the same kind of database connection that powers actual applications you use every day. So, now before we write a single line of code, I want to tell you how I teach because it matters. I don't do theory first. So we're not going to spend 20 minutes on slides before touching code. We're going to build something and I'll explain every piece as we go. By the time you're done, you won't just have code that works. You'll understand why it works. So basically that's the difference between someone who can copy code and someone who can actually write it from scratch. And my goal is always the second one. So here's what we're building today. A price tracker, and it's going to connect Python to a PostgreSQL database. Then we're going to create a table to store price data, insert some records, and then pull them back and display them nicely. So let me show you exactly what the finished result looks like before we build it. So I'll run my code. Okay, so what you're looking at right now is live data coming out of a PostgreSQL database. Python fetched it, formatted it, and printed it to the screen. Each row you see here is a record we stored in the database. So it contains an asset name along its price and a timestamp showing when it was captured. Now this version uses mock data. So we're simulating what an API response will look like. But the database logic, that's identical to what a real financial application uses. The only difference in production is the source of the numbers. And here is what I want you to notice. This isn't just a print statement. This was data that was stored in a real table with real columns and in a real database. And then we queried it back out. So that's a full data pipeline, even if it fits in one small file. All right, let's now build it from scratch, and I'll explain every single decision along the way. So I'll just clean this so that we have a file that is empty. So, okay, step one, before Python can do anything with our database, it needs a connection. So it needs to know where the database is, what's it called, and who's asking. You can think of it like this. The database is a filing cabinet sitting in another room. Python is you, and to get to that filing cabinet, you need a key, a name, and you need to know which room it's in. So that's exactly what we're about to give it. And the library that handles this connection is called psychopg2. So it's the standard PostgreSQL adapter for Python. And we'll begin by importing it. So I'll type import psychopg2. And in any case, it's not installed in your environment. You can simply go to your terminal and type pip install psycopg2 hyphen binary. So that will run in my terminal. And you see it's already installed, so the requirement has already been satisfied. So we'll proceed to the next thing. So good, now we need to create the connection, and I'm going to type this out and explain each parameter as I go. So con is equals to psycopg 2 dot connect, then opening parenthesis, then we need to provide the host. So the host will be localhost. Okay, we need to provide the name of the database, so it will be price db. We need comma and another comma, then proceed to the next line. We need to provide a user, so it will be, name of the user will be Postgres. And finally, we need to provide a password. So, okay, ideally, the password will be stored in a .env file. So this is to prevent hard coding your secrets in your files, because anybody can go and steal your password and get access to your database. That's why you need to store it somewhere in a .env file, especially in production environments. Okay, so now I'll walk you through this. So the host is where the database lives, and in our case, it's on this same machine. So we say localhost. Then the database is the name of the specific database we want. The user and the password are our credentials. Okay, now here's something important that I need you to know. So this connect call, when it runs successfully, it opens a live channel between Python and PostgreSQL. So that channel stays open until we explicitly close it. And we'll do that at the end. Now, once we have a connection, we need one more thing before we can actually run queries. And it's called a cursor. And this is something a lot of beginners get confused about. So let me be very clear. If the connection is a phone line, the cursor is your voice on that line. So the connection is just the open channel, and the cursor is the thing that actually sends your SQL commands and brings back the results. So you can't send a message without a voice. So I'll type it out. Cursor equals dot cursor, opening and closing parentheses. Perfect. We now have a live connection and a cursor that's ready to work. And so we'll use them. Now, the second step is creating the table. Now, we need to build our table. And a table is just a structured storage container inside the database. You can think of it as one sheet inside a massive Excel workbook. So it has columns, and each column has a specific type, and every row we insert has to fit that structure. So now we're going to design ours carefully. Because the columns you choose and the data types you assign, those are real decisions that affect performance, storage, and reliability, even in a small project like this. So casa.execute, then we'll have an opening and closing parenthesis. And what I'm going to do here, yeah. So yeah. So what I actually need to type out is our table, whereby we'll be storing the data. So create table if not exists prices, and we need an opening and closing parenthesis. Then we'll have our ID, serial primary key. We'll have the name, the asset, variable character will store 100, and needs not to be null. Then the next thing will store the price to be numeric up to 10 and 2 decimal places. Also be not null. Finally, we need to store the timestamps. So captured at timestamp default now. So see, it is not closed. Okay, can just do away with that, and okay, need to debug this to so yeah. Now let me explain the design decisions here, because this is exactly the kind of thing that comes up in technical interviews. So we'll start by ID serial primary key. So serial basically means that Postgres automatically generates the next number for us every time we insert a row. Primary key here is the unique identifier. So no two rows can ever share the same ID. We never have to think about this column, and so it manages itself. We'll move on to the asset variable character, opening and closing parentheses 100. So variable character here means that this will be the variable length of the text, and 100 is the maximum number of characters. So asset names like Bitcoin or Apple stock are never going to be longer than 100 characters. So this is the right fit. And the price numeric, opening and closing parentheses, 10 to Now we have a reason why we are using numeric instead of float. And this is a genuinely important question. And it normally comes up during interviews. So float is an approximate number type. And due to how computers store floating point values, you can get tiny precision errors. So if I were to go to my Python interpreter and let's say I type 0.1 plus 0.2 in Python. So you'll get a number such as, let's try that. Okay, so if you're to type that in a Python interpreter, you'll get a number such as 0.3000004. And for most things, that's important. But for financial data, it is not. So the reason why we are using numeric instead of float is that numeric is exact. And every serious financial system uses it. Okay, we'll then proceed to the final thing, which is capture that timestamp default now. So this column stores when the price was recorded. So the default now basically means that PostgreSQL sets it automatically the moment a row is inserted. We never have to pass it in ourselves. And one last important thing before I forget is if not exists. So basically, this means that if we run the script multiple times, it won't crash when the table already exists. So it just checks, sees if it's there, and then moves on. Small detail, but it brings a very huge difference in practice. And now we need to save this change to the database. So in PostgreSQL, changes don't automatically persist. You have to commit them. So I'll now commit them. Con.commit, opening and closing parentheses. So you can think of commit like the save button. You've typed the document and now you're saving it. So without this line, the table will only exist in memory and disappear the moment the script ends. We'll move to the next step, which is inserting the data. Now we have to put our data in our PostgreSQL database. And we are going to create a dictionary of mock prices, which simulates what you'll get back from a live API like CoinGecko or a stock market feed. So the dictionary is just standing in for the real thing. So we'll move on to that. So I'll type prices equals to, then we'll have the opening and closing curly braces. And the first asset we have will be Bitcoin. So Bitcoin, the price can put something like 75909.76. Have the second asset, take it to be Ethereum, something like 4300.56. The third asset we'll have is, let's say, Apple stock. So we'll give this a price of, hold on, forgot. So we'll have Apple stock, and I'll give it a price of maybe 450.54. We'll have Tesla stock. So we'll give it a price of let's say 245.21. And finally, we can have gold. We'll give it a price of 2.43. Okay, from there, we'll create a for loop. So for assets in price in prices dom items, penny and closing parentheses. We'll have our cursor execute or send the SQL command. Then we'll insert into our database, and what we'll insert is the asset and the price. Then we'll have our values. Then we'll have our modulo. So we'll format the string. Then have the assets and the price. Then we'll commit this. So I'm getting what is not closed. Inserting to so this is real debugging in practice. You can see this wasn't closed, so we'll close that. Perfect. So all right, there is something in this code that I want you to pay close attention to, because it's one of the most important concepts in backend development. So do you see the modulo s operator in the insert statement? So those are called parameterized placeholders, and here's why they exist. So imagine instead of using this modulo s operator, I wrote the query like this, and I'm just going to describe it, not type it. So let's say type insert into prices values, then we'll have an opening parenthesis, then I'll type plus the asset variable plus, then we'll have a closing parenthesis. So it looks fine, right? But what if someone passed in a value that wasn't a price? What if they passed in a string that contained actual SQL code? Now, the attack is called SQL injection, and it's one of the oldest and most destructive vulnerabilities in software. So a malicious user passes in something like 0, close the brackets, semicolon, then drop table prices, then a double dash. And if your query is built by concatenating strings, the database executes it, and then your table is gone. So the modulo S approach completely prevents this. When you use placeholders, psychopg2 takes the values, which will be the asset name and the price, and then it passes them to the database separately from the query itself. So the database treats them as pure data. It is literally impossible for them to be interpreted as SQL code. Now, this is not optional. This is how every professional writes database inserts. So if you ever see code that builds SQL queries by concatenating strings, that's actually a red flag. And in an interview, pointing that out shows a level of security awareness that most junior candidates don't have. Okay, so now we've inserted our data and committed it. So let's get it back out. And we'll move on to step 4, which will be fetching and displaying the data that we have. So this is the part where everything comes together. So we're going to write a select query, pull our data back out of the database, and display it in a clean, readable format. So I'll type cursor.execute. Then have so we'll have that. Then we're going to select the asset, the price, and the timestamp it was captured at. Then from prices database, and then we're going to order it from the highest to the lowest price. Then have that. I'm going to have rows is equals to cursor dot going to fetch all, then we're going to print it out. So backslash going to have price tracker. Going to have another print statement. This so we're going to have opening and closing. Going to have the asset, be less than 20. Going to have another curly brace, which will be the price colon, it will be greater than, and finally going to have the time. So time colon, then sure unit expression expressing. So yeah, this will be real-time debugging in practice. So this wasn't closed. I need to close this. So perfect. Then we're going to have the final print. Hyphen. So you need not worry about this. This is just for formatting purposes. Then going to have a for loop. Going to have the asset, the price, is equal to. Then we're going to have. We're going to print it out. So then we're going to have a curly brace. That's the asset. So stand 20. Going to have the dollar sign. Going to have the price. Then we'll have the final curly brace, which will be the string, and greater than sign, and 26. So since I forgot to close this, so yeah, then we're going to close our connection. Cursor.close. Then we're going to close the connection. So okay, let me explain what's happening. So after we execute the select query, the results are sitting inside the cursor's memory. So the fetch all function takes all of them and returns them as a list of tuples. And one tuple per row, one tuple is basically a row with each value inside matching the columns that we selected. So when we loop through rows and unpack each one into assets, the price, and TS, we're just pulling out 3 values from each tuple. And the F string formatting is just to make it look neat when it prints. So we have an order by price description, which sorts the results from the most expensive asset down to the list. So in a real dashboard, you might sort by captured ads description instead. So you only see the most recent prices first. So one word actually changes the whole perspective of your data. And then we have this, the last 2 lines, the cursor close and the connection close. So you always need to close your connections when you're done. Our database can only handle a certain number of open connections at once. So in production, leaving connections open is a common cause of performance issues and outages. So it's actually a small habit that matters a lot at scale. So I'll run this script to see if it works. So Python, then the name of the script, real time price tracker dot py. So we actually see that the prices of the assets are actually being printed, though. Okay, we have the Bitcoin, the Ethereum, the Apple stock, and the Tesla stock. So there it is, your price tracker. So data in a PostgreSQL database queried with Python and displayed cleanly on the screen. And here's what I want you to notice about the code we just wrote. It's about 58 lines and it's readable. There are no tricks in it, but it demonstrates connection management, schema design, parameterized queries, and data retrieval. Those are exactly the concepts you'll be asked about in data engineering or a backend Python interview. So let's take a step back and look what we've actually built in the last 30 minutes or so. So we've basically connected Python to a real PostgreSQL database using PsychoPG2. We then moved on to designing a table with production appropriate data types. And we talked about why those choices matter. We then went on to insert, we inserted data using parameterized queries and then explained exactly why that protects against SQL injection. We then wrote a select query that pulls data back out, sorts it, and displays it cleanly. So basically, this is a complete data pipeline. It may be small, but every concept in it, be it connection management, schema design, safe inserts, and querying. So those concepts don't change when the project gets bigger. They just get applied to large data sets and more complex structures. So now's here what I'd want to do in full sessions if we continue. So we actually used mock data, but in the next sessions, we'll replace this mock data with a live API. And we'd use CoinGecko for crypto prices, which is completely free and no API key is required. So your database will be pulling real-time market data automatically. After that, we'd set up Airflow to run the script on a schedule, which will be every hour or every 10 minutes or whatever duration you need. So the database stays updated without you touching anything. Then after that, we add AWS into the picture, which will be storing data in the cloud, connecting it to an RDS instance, and building a pipeline that runs on infrastructure rather than your laptop. And by the end of that roadmap, you'd have a real project on your GitHub, not just a tutorial clone. A project that you actually built and understand from the inside out and can explain it confidently in an interview. And that's the kind of thing that actually moves the needle when you're applying for roles in data engineering or backend development. So if this style of teaching resonates with you, I'd love to continue. So we can start from exactly where you are and build at whatever pace works for you. So thanks for watching, and I'll see you in the next session. Goodbye.